Well, grade 11s, in this lesson, we're going to be looking at functions. In particular, we're going to be looking at what is a function. We're going to be revising that from earlier years. What do we mean by the word function? If a graph is a function, what does that mean? And then also, we're going to be looking at the straight line graph, or what is called the linear function. Okay, but let's just go and quickly revise from grade 10 days what we mean by the word function. Now I've got a little graph here. Now I want to show you something, that this is the parabola y equals a half x squared from grade 10, and if you notice, if your x value is negative 2, if I just make up negative 2 there, I've got x is equal to 0, and I've got x is equal to 2. Those were chosen at random, if you remember, in grade 10. And if we then if we work out the y values corresponding, let's have a look at this. A half of x squared, so you put x into there, then you see that's the formula there. That's the formula for the parabola. So it's going to be a half multiplied by 0 squared, and y is equal to a half into 2 squared. Okay, now the question is, what are the y values? Well, then y here would be a half of 4, which of course gives me, if you think about it, it's going to give me a half of 4, which is 2. So this would give me 0, because 0 squared times anything is just 0, and that gives you a half of 4, which of course is 2. Now look at this. For x is minus 2, the y is 2. So I plotted the point, minus 2 and 2. Then I've got 0 and 0, and then if x is 2, then y is also given by 2 there. Alright, now notice that this is the x value, and that's the y, the corresponding. There's an x value and a y. There's an x and a y. And you'll probably notice that if you look at this x, the negative 2, it associates with only one y value. The 0 here associates with 0, and 2 associates with 2. So all these x values, if you look at that, each x value on the graph is connected only to one y value. When that happens, the graph is referred to as a function, if you can remember that from grade 10 days. And how we do it, if you took a little ruler and you moved across, like if I went across here, let me change the color, but say for example you moved across, you'll notice that you only ever, as you move from left to right, you only ever cut the parabola once. You cut it once. As you move, it will never cut more than once. Okay, in other words, one x associates with one y value. Now this is what we call a function. Okay, now guys, let's have a look at this example quickly. If you think about this here, this parabola is lying on its side. Now if you look at that x, what do you notice is that x is associating with a y value of 2. The 0 is associating with a y value of 0. Now notice this x associates with a y value that's different to this one. But now you come along and look at this. I want you to look here, and I'm going to draw a little line down here. Do you notice that the x value is the same for 2, and yet the same x value is associating with negative 2. Okay, now when this happens, one x is associating with more than one y value. Here there's this x associates with one y, but the problem is, the moment this happens, the moment you take a vertical line and it cuts twice, the graph is not a function. Now that's revision from grade 10 days, but it comes up in matric a lot. I'm not going to really worry too much about this now, but just to sort of mention it, okay? So be very careful with that, this whole concept of a function. So if you've got any graph, we can look at it like that. If you take any graph, it can be a graph doing like that. That's a function, because look at this. Wow, you only ever cut once. If you move from left to right, a vertical line will only ever cut the graph once. But the moment you have this sort of thing, look at that, it cuts it twice, there and there. It cuts it twice. So this is not a function, and this is a function. Okay, so if you take your ruler and you move across from left to right, and it only ever cuts once, then you know the graph is a function. But like a circle as well, for example, circles are classic. They're not functions because you can see that you're cutting in more than one place. If you go there, you're cutting in more than one place. Okay, and that's what a function is not. Okay, so clearly, so let's just double check this. I'll give you a graph and I do it like that, and then I give you another one and I do it like this. Now look at this. If you ever look at this graph here, you only ever going to cut once. Look at that, it cuts once as you move from left to right. This is a function. But look at this one, it might cut fine there, but look at that, if you go there, it's actually cutting in 3 places. Look at that, 3. Again, not a function at all. Okay, so be aware of that with graphs that are functions and not functions. But leading on to this is the important thing that we call fx notation or functional notation. And this is going to be very important. If you look at this, if I said to you just to revise this from grade 10 days, if fx is equal to 4x, what do we mean by this? This is red. If you read it, it says f of x is equal to 4x. Okay, the f of x is equal to 4x. And what happens, it really, if you think about it, by the way, if you think of the word domain, those would be the x's, if you remember, and range would be the y value. So if you go back here, if you look at this, the x's here, these guys are referred to as the domain, the x values, and these are called the range, the corresponding y values. So you can see, if you go back a bit to our other one here, what is the domain? The domain would be all these guys here. That's minus 2, 0, and 2 on the graph. The range would be the corresponding y values. Okay, so if we go back to this, we've got domain and range. So the moment, if you look at this, so if I said, to example, if I said to you, if you look at the f of x, okay, what this means, it's actually the y value, okay, corresponding to an x value, okay, given x value. So in other words, if you have a look at fx is equal to 4x, if I said to you, what is the f of 1? You would then say 4 times 1, which is 4. Okay, you'd replace those x's with 1. And if you remember, that is your x, and that is your y. So y is equal to the f of x. Okay, that's important there. For x equals whatever x is 1, the y value is 2. And when you represent that on a graph, it's important to understand this. If you look at this concept, okay, if you look at x is 1, 1, 2, 3, 4, the y value is 4. Okay, so if x is 1, what is your y value? Your y value is 4. So remember that the 4 is the f of 1. Okay, you used the rule fx is 4x, and you chose your x value to be 1. You substituted it in there for 4 times 1, which is 4, which is your corresponding y, and that's your x. Okay, so when you think of it, if you've got an x value of 1, the f of 1 is the y value determined by this equation, which is given to you. Okay, we're going to look at an example just to clarify fx notation, and then after that we'll practice a few things and see if you've mastered this. Okay, have a look at this little grid here. I'm going to create a rule. Let's consider the function fx is equal to x plus 1. Now we're going to really revise this. It's so important. Remember, this is your y value corresponding to an x. And I'm going to give you a domain. Now a domain represents your x values. And let's say the domain would be minus 1, 0, 1, and 2. Let's make up those. That could be chosen at random. So let's work out the corresponding y values, which is they refer to as the range, and then we'll put them on this graph here. Well, what would be the f of negative 1? Well, simply put, the x on the left is negative 1, so the y value, you go into this formula here and you say, well, x plus 1 is actually the x plus the 1, which is 0. So that's going to give you your part of your range. Okay, let's have a look at the f of 0. Well, that'll be 0 plus 1 because that's x, x plus 1, and that gives you 1. What is the f of 1? Is 1 plus 1, which is 2, and the f of 2 is 2 plus 1, which is 3. Remember, what are you doing? You're simply taking these x values and plugging in them into x plus 1. And you get the f of minus 1 is the y. So these are your y values. So the range of the function would be this. Have a look here. The range would be made up of 0, 1, 2, and 3. That is your range, 0, 1, 2, 3. Okay, now we've got the domain and range. And what we could do is we could represent these points on the number plane. For example, if x is negative 1, what was the corresponding y? 0. So it was minus 1. Here we go. Minus 1, 0 is there. Okay, then you had if x is 0, what was the corresponding y? 1. If x is 0, y is 1. So it was 0, start at 0, go up to 1. Then it was x is 1, y is 2. X is 1, y is 2. There we go. And if x is 2, the y value is 3. Now look at that. These are your x's. So your domain would be all the x's, and the ranges would be all the y values here. So in other words, if you took, for example, this point, the x would be 2, but the y value is the f of 2, which is, remember, it doesn't mean f times 2, but the f of 2 is, of course, 3, which of course it is. So for the x equals 2 from the domain, the y value in the range is 3. If x is 2, f2 is 3. So fx is really your y value corresponding to an x value there. And of course, you can do it with all of those. This would be the point minus 1, 0. This would be 0, 1. Watch out for those. But remember, if you look at minus 1, 0, that's the same as the minus 1, the f of negative 1. That's the corresponding y value. F of negative 1 is 0. So remember that fx is simply the y value corresponding to that given x, subject to a specific rule, like, for example, in this case, x plus 1. Alright, so that's important. Let's practice a few more things with fx notation. Alright, guys, in a second example here, let's have a look at an example 2. What we can do here is, if I gave you fx as something else, not 4x or x, x plus 1, what if we go 2x squared minus 3? We know from grade 10 that's a parabola, but I'm not going to worry. And we want to determine number A is the f of 4. Now, what does that mean? It says your x value is 4, and we want to know what is the corresponding y value. Okay, now how do you do it? Well, you've got fx is equal to 2x squared minus 3. So we want the y value corresponding to x is equal to 4. So you plug in 4 into x's place. Okay, you substitute that into there. Okay, and what does this come to? The f of 4, the y value, is 16 times 2 is 32 minus 3. So then f4 is going to give you 29. Okay, and then b, what if your x value is a half? Okay, well, we know that fx is equal to 2x squared minus 3. Okay, so then we've got f of a half is going to be 2 times a half squared minus 3. So f of a half is equal to 2 times a quarter minus 3. So what does that f of a half give us? Well, 2 times a quarter is a half minus 3, and then that simply comes to, we can say it's a half minus, okay, that make it 6 over 2, which is 3. And then we can say the f of a half is going to be, very simply put, is going to be negative 5 over 2, which of course is minus 2.5 if you want to do that. Okay, good. So in other words, if you look at it on the graph, the x is a half, but the y is minus 2.5 there. Okay, and you could plot that point. So remember, if that's x, that is the f of that x value there.